state the domain in interval notation and identify any holes written as ordered pairs in the graph of this rational function. So first off, we want to factor to see what's involved in this rational function. So we have r of x equals, the numerator factors of 12, 4, and 3, x minus 4, x plus 3. The denominator factors is a difference of squares, x minus 3, x plus 3. Okay, so first off, the denominator gives us, before any reduction happens, we can see that x cannot equal negative 3 or positive 3. This will give us our domain. So our domain interval notation would be from negative infinity to negative 3, to the left of negative 3, in between negative 3 and 3, so union negative 3 to 3, and then to the right of 3, union 3 to infinity. This will make sure we get all values except for the two values that make the denominator 0. So here we have our domain. I keep not getting my line straight today. There we go. Next up, we have a reduction. Now some people do the reduction first before they do the domain, and then they don't see the negative 3 as a problem, but it is. So make sure you get the domain after factoring, great, but before you do any simplification. This reduction gives us that x equals negative 3 is part of a whole. Okay, so instead of negative 3 being an x-intercept because it's in the numerator, the x plus 3, or a vertical asymptote because it's in the denominator, these reduce, giving it that this is part of a whole. So we need to figure out, if I let x equal 3, negative 3, the rest of this function, the simplified form of r of x, that's what we plug in negative 3. So we get negative 3 minus 4 over negative 3 minus 3. That's negative 7 over negative 6. So we get 7/6. So the whole is at the point negative 3, comma 7/6. Now, if you try to plug in negative 3 into the original unsimplified form, you will get a 0 over 0 error in the domain. So you have to plug the negative 3 into the reduced form so that you can find out what the y value is for that whole. All right, hope this makes sense.